So, once again, welcome back, children. Today, we will do the chapter metals and non-metals. So, let us try to understand what are metals. Metals are those elements which loses electrons to form electropositive ions. Let us take few example. So, sodium. Sodium, if you see the atomic number of sodium is 11. If its configuration is 2, 8, 1. So it has got one valence electron. And if it loses that one valence electron, it will have a noble gas configuration. So what happens with sodium? It loses that electron to become noble gas, to become inert. So sodium loses one electron to form Na+. And Na++ is an electropositive ion. Same if you look at magnesium. Atomic number of magnesium is 12. Its configuration is 2, 8, 2. And it has got two valence electrons. It loses those two electrons to form Mg2+. So any metals, they will lose electrons and they will form electropositive ions. What are non-metals? Non-metals are elements which gains electron to form electronegative ions. Let's take one example, chlorine. Chlorine's atomic number is 17. Its configuration is 2, 8, 7. It needs one more electron to complete its octet. So chlorine gets that one electron and it becomes Cl-. Cl- is an electronegative ion. Oxygen, atomic number is 8. Configuration will be 2, 6. It needs 2 electrons to complete its octet. So oxygen gains those 2 electrons to form O2-. So non-metals gains electron to form electronegative ions. What are metalloids? Metalloids are elements which shows characteristics or properties of both metals and non-metals. Sometimes they are also called semi-metals. Example of metalloids or semi-metals would be silicon, germanium. Let us know the difference between metals and non-metals. First property is ductility. Ductility means to draw metals into very thin wires. We have wires in our house. All these wires invariably are metals. So metals normally are ductile, non-metals are non-ductile. But there are exceptions in metals also, in non-metals also. Metals exceptions are zinc, arsenic, antimony. They are not ductile. Non-metals exception will be carbon fiber. Metals are malleable. Malleable means they can be beaten into very thin sheets. Whenever we see of some sheets, these are malleability. That is what is malleability comes into picture. There are again some exceptions like zinc, arsenic and antimony are not malleable. Non-metals in general are not malleable. Metals have got very high tensile strength. Means they can bear a lot of strain without breaking. You can bend them but they may not break. But there is an exception to that rule also. Zinc, arsenic and antimony are again which has got low tensile strength. Non-metals, they do not generally have high tensile strength. They have low tensile strength. Again, there is an exception in non-metals and that exception is carbon fibers. Metals are very good conductors of heat and electricity. Non-metals are poor conductors of heat and electricity. Silver, if you see, is the best conductor of, among the metals, the best conductor of electricity. Among the metals, again, there are exceptions which are poor conductors of electricity and heat. One is bismuth, one is tungsten. They are poor conductors. Graphite is an exception in the case of non-metals. Non-metals are supposed to be poor conductors of electricity except graphite. Again, metals are sonorous, non-metals are not sonorous. Sonorous means which makes sound. If you heat a metal, it makes some sound, ting, tang. Those sounds is sonorous. Or metals generally makes that sound. Excuse me. Metals have high melting and boiling point. Non-metals have low melting and boiling point. There are again some exceptions to it. Potassium, mercury, gallium. These are generally liquids. You see, mercury and gallium generally liquid, sodium, potassium very soft. Same in the case of non-metals, they've got low melting and boiling point. Again, exception are there: carbon, silicon, boron. Carbon in the form of diamond, they have a very, very high melting point it has got. Same, ionic compounds, if you talk about metals, metals are very hard, except there are potassium and sodium. They can even be cut with a knife. Non-metals are generally soft, except diamond. Again, metals have luster and they've got very high density. Sodium and potassium are those exception to the metals which has got low density. If you talk about non-metals, non-metals are non-lustrous, they've got very low density. Again, iodine and graphite are those two non-metals which has luster. Now let us talk about the formation of ionic compound. What are ionic compound? Ionic compounds are those compounds which are formed by transfer of electrons. Transfer of electrons means where one element donates an electron, another element receives an electron. Basically, metals and non-metals forms ionic compound. Here you have got two such examples I'll take, and that's a part of your syllabus, so just listen to it properly. The first one is the formation of sodium chloride. As I told you before, sodium's atomic number is 11. Its electronic configuration, if you write, is 2, 8, 1. So it has got a valency of 1. So it loses that one electron to become Na+, electropositive ion. Chlorine, if you see the atomic number is 17, configuration is 2, 8, 7. Its valency, again, it needs one more electron to complete its outermost shell. So it has got a valency of 1. So Na plus Cl minus, they are hold together by electrostatic force or attraction, and they form NaCl. NaCl is a common salt which we use in our house. Formation of magnesium chloride. Magnesium, if you see the atomic number is 12, its configuration is 2, 8, 2, and its valency is 2. So it loses that 2 electrons to form Mg2+. Chlorine, again, as usual, I told you, atomic valency is 1. So it gains that 1 electron to form Cl minus. So magnesium has got valency 2, chlorine has got valency 1. So again, they are hold together with electrostatic force, and the formula is MgCl2. So it forms a compound. Let us discuss about the properties of ionic compound. Ionic compound has got basically the 5 properties. Ionic compounds are generally very hard. Ionic compounds has got high melting and boiling point. Ionic compounds are usually soluble in water but insoluble in organic solvents like benzene, ether. Ionic compounds are very good conductors of heat and electricity. Ionic compound, the chemical reaction between ionic compounds is very, very fast. Now let us start with the first one. Why ionic compounds are very hard or hard crystalline solids? The answer to it is that because they held together very, very strong force of attraction, the electrostatic force of attraction. And they are closely packed in the crystalline, in the crystal lattice. So they are very hard to break down. Second question can be asked, why ionic compounds have got high melting and boiling point? As the same, they hold together by very strong electrostatic force of attraction. Between the oppositely charged cations are positively charged, and anions, which are negatively charged. Hence, a large amount of energy is required to overcome that force of attraction. Hence, they have got high melting and boiling point. Again, why ionic compounds are usually soluble in water but insoluble in organic solvents? The answer to it is that water, if you see, has got a high energy of solvation. Since it has got a high energy of solvation, and moreover water is a polar molecule, it could easily overcome the electrostatic force of attraction of the ionic molecule. Similarly, if they ask you another question, why ionic compounds are good conductors of heat and electricity? We should understand, ionic compounds are good conductors of heat and electricity because they dissociate into ions in the molten state or in the aqueous solution. Means if you dissolve ionic compounds in water or you melt it, they dissociate and forms free ions, and these free ions are free enough to move around and conduct electricity. But remember, ionic compounds in the solid state do not conduct electricity. Why? Because their cations and anions are hold together by electrostatic force of attraction. So the mobility is not there, and hence no conduction is there. Again, the chemical reaction between ionic compound in aqueous solution is very fast. Remember, ionic compound in solution reacts faster than molecular compounds or covalent compounds. The reason to it is that because ionic compounds break apart and they form free ions. So since they form free ions, there is no more longer that force of attraction holding it together. Hence, the reaction becomes very, very fast. Thank you. We will continue with the next part of the chapter later.